How does a deorbit burn guide spacecraft reentry? Imagine a spacecraft racing through the vastness of space, orbiting Earth at incredible speeds. But what happens when it's time to come home? That's where a deorbit burn comes into play. This maneuver is essential for safely guiding a spacecraft back into the atmosphere. A deorbit burn is a controlled engine firing that reduces the spacecraft's orbital velocity. This reduction is necessary to initiate its descent from orbit. The spacecraft must slow down enough so that its trajectory intersects with the atmosphere. This is done by firing thrusters in the opposite direction of travel, known as a retrograde burn. Now let's talk about timing. The deorbit burn must be executed at just the right moment. If it happens too early or too late, the spacecraft could end up re-entering overpopulated areas or miss its intended re-entry corridor entirely. The magnitude of the burn also plays a role in determining the angle at which the spacecraft enters the atmosphere. This angle is critical because it affects heating rates and deceleration forces during re-entry. When the spacecraft re-enters, it encounters atmospheric drag, which slows it down rapidly. This process generates intense heat due to air compression and friction. The deorbit burn sets the stage for this re-entry. It ensures that the spacecraft enters at an angle that is steep enough to avoid skipping off the atmosphere but shallow enough to prevent excessive heating that could damage the vehicle. Mission planners carefully calculate the parameters for the deorbit burn to target a safe re-entry zone. Often, this zone is over remote ocean areas to minimize risks to people and property. For example, cargo spacecraft like the Russian Progress use precisely timed deorbit burns to ensure they re-enter over the Pacific Ocean, where any debris can safely fall into the water. For smaller satellites, advanced deorbit systems may utilize solid propellant motors with spin stabilization. These systems provide reliable deorbit burns and help comply with space debris mitigation policies. This ensures that satellites deorbit within required timeframes after their missions are complete. In essence, a deorbit burn is a critical maneuver that guides a spacecraft's path into the atmosphere. It controls where and how it re-enters, ensuring safe disposal of spacecraft while managing heating and forces. This process is vital for minimizing risks on the ground and ensuring a successful return journey.